Hello, good morning or good afternoon. Thank you all for joining the DAM webinar series, The Art and Practice of Managing Digital Assets. Today, I will be your host. My name is Elliot Zediga from Adobe. I'm joined today with one of my esteemed colleagues, Dr. Jonas Dahl, and we're going to be talking about one of those topics that, we seem to be just around us everywhere. The topics are around machine learning, data science, artificial intelligence. The reason why we feel like it's everywhere is because it is actually, matter of fact, everywhere. Where we're seeing it in our smartphones from Siri, being able to recognize our speech or our accent without even training the system, or when we're browsing around on our TV using Netflix, while Netflix is predicting what we'll even watch before we even want to watch it. Automakers are using this and planning to use this and add this into their cars. Cameras are embedded this technology into the devices. We're seeing this technology continuing to just spread as well as software continues to eat the world. So today we're going to talk about that in the context of DAM. So we're going to do a bit of a refresh and talk about some of those content velocity challenges that we've been expressing, and how these new technologies might be able to help us. We have Dr. Jonas Dahl in here today, who can help us demystify some of the machine learning and data science techniques. So if it's one of those things that you've been curious about, how it works, how accurate is it, how can you take advantage of it in DAM, Jonas will walk us through some of the fundamentals of how that works. So we'll keep it at a very, very high level. And then we'll hop into, after that, some 5 practical applications with DAM. So one of the things that we've seen is content recognition and all those different recommendations, things that have been talked about, but just now over the last 5 years, we're starting to see those technologies actually become useful in the context of the enterprise. And then we'll end with some tips and tricks, so we actually see some of those going throughout. So just to kind of refresh on the core concepts, we're thinking about the concept of DAM and what we've seen happen over the last 5 to 6 years is we know that it's getting more complex. We have more and more people involved in the process who want to centralize and access that content in a centralized way. We're getting more and more demands to produce that content, and we're seeing a higher level of complexity as we introduce more people, more content, more objectives into the system. So we're putting a lot of strain on that system. And we've heard a lot of feedback from our users. And these, a lot of the feedback that we see here, these quotes, these are the ones that we've heard, our customers early on in the process as we're engaging with them on a DAM initiative. But these aren't exclusive to, I think, what we've seen. I mean, these are probably quotes that you've seen as well, where I can't find the digital asset, one of the key asks to begin with, the process being better, scaling, personalization, and then you start to think about how things aren't getting easier. It's actually getting much, much harder. And if you are the DAM administrator or the one leading that project, this is sort of how you feel, where you probably buried in imagery, video, content, requests. We're going to need some assistance somewhere. And I think there is some hope. I think one of the key things I want you to think about as we continue to talk about this concept today is, we are surrounded by data, but we're starved for insights. So the key thing is, how can we take advantage of that data in a very new and interesting way to make the rest of our team and our business much more productive, right? So how are we going to use that data to meet those content velocity challenge of scale and producing content and managing it at scale, or distributing it at scale, or getting that data? So, when you think about that, data has been the bedrock of DAM. We know we need a lot of metadata, from the descriptive metadata that's describing what kind of content that is, to structural and technical metadata that might be showing you how assets are linked together, or maybe taking attributes directly from that camera. Administrative data, metadata, rights management, preservation. There's lots of metadata that we are already using. And then what we're going to talk about today is maybe just one aspect of that, is the descriptive metadata. How can we enhance or adapt that and make that part a bit better? We're not saying sort of throw away the rest of that metadata. We know that the rest of that is actually critically important, but how can we use this along with some of the new technologies that are coming around? Second, we know that analytics and data platforms are out there already. They're already publishing a lot of our content. They're already out there analyzing how they're being used on different web properties, on different mobile devices. And that's great. I think, we're going along with that. That's sitting with the analytics team. I think one of the key opportunities for digital asset management is how do we get this data back into the dam? And, you start to think about that. Why do we want to do that? One of the first things that comes up is, understanding that asset that's in the dam, how often it's been used. Now, one of the things that we believe is, this isn't something that should be just reserved for the dam administrator to kind of run reports and kind of understand those, but for the actual users themselves. Imagine if this data was actually exposed to the search interface or to their campaigns to actually really understand when they're coming down to, selecting from a few set of images or videos or other pieces of media, which ones should they use, and have some data-driven decisions around that. So, understanding how things are performing on different channels and which ones are resonating, all that information shouldn't be kept in another silo, but how do we pull that back into the dam, likely connected with the digital asset itself and the metadata structure. So, you start to look at those two things. Let's look at the analytics. You look at the content intelligence behind that, and we all understand that the future of DAM is going to be very different. Just like the rest of the software world has changed by these technologies, where we're starting to see the data coming back into the system and machine learning taking advantage of the latest algorithms to help us be much more productive. So, we're going to look at the analytics to bring those insights back into our business. So think of every digital asset you have out there, everyone that's published, as a signal that can provide insights and recommendations to your business. So no matter where that's hosted, that's going to be one piece there as well. And then think of scaling automation. We don't want our teams, our people on our teams, some people call them resources, but they're actual people spending their time doing tasks that they could be spending their time doing higher value tasks for their business. So that lower value monotonous task that we would prefer to have automated and scaled, let's look at different ways to take advantage of that in our business to make sure we get much more efficient. So with that, I'm going to turn it over to Jonas to talk a little bit more about how we got here and talk a little bit more about some of the core concepts when you start to think about bringing machine learning, data science, and artificial intelligence into DAM, and what we can do from there. Jonas?
Great, thanks, Elliot. So first, I wanted to take a step back and discuss a little bit, give a background of how this whole scene evolved. Because artificial intelligence and machine learning they're not new concepts. So I just wanted to help you understand why is now a good time to think about this, and why is now a time where these techniques can actually solve real business problems for us. So I would say one of the first stages of machine learning and artificial intelligence were actually all the way back into the 50s and 60s, where we're talking about things like let's build a machine that can compete against humans in some kind of well-defined game. Chess is a very good example. And it took decades from in the 60s, you had chess engines that could, play like, at the strength level of a beginner, up until the 90s, where a chess engine could actually beat the world champion. So I think it's important to kind of take note of that timeline, that we're talking about decades here. And then I would say the next really important thing that happened in machine learning is in the 90s, where we started seeing some very specialized applications of machine learning that could solve real business problems. And one great example that I love is the processing of bank checks, that already in the 90s, millions of bank checks were processed per year by artificial intelligence, which is remarkable and it's real business value. But it's not until recently that, several decades later, that we're seeing that this has much more of a wider presence. And really the reason behind that, and I'll come back to that and talk about it in a bit more detail, is that now the models are much broad. They can be applied to a wider range of problems, and I'll talk a little bit about why that is. But from this, I hope you can appreciate that the timelines are really being compressed here, right? We went from several decades, maybe 3 or 4, for the first piece. Then the next piece was like 2, and now we're talking about every year accuracy and precision is going up for these things. So let's see why now. What happened in all this time, and I'd say there are really 3 things that's driving this. One is obviously computational power has become much cheaper and much stronger, much faster. Everyone knows that. That's one piece of this, obviously. The other thing is algorithms. That there's some development there, but you would be surprised as to how similar the systems are now compared to like 20 years back. And then the third piece here, which I think doesn't get emphasized that much, but it's really driving a lot of the development right now, is the whole data revolution. Access to data sets turns out to be extremely important. And because you need a lot of data to train your models. And it's not until recently that those data sets were actually available, primarily due to the internet, that now it's easy to share really large data sets. It's easier to compile data sets through search engines and crowdsourcing, etc. But the confluence of those 3 things recently have really pushed this forward. So let's go in and take a look at how it actually works, and why is deep learning in the context of image labeling and classification much better than what we have before. And this is kind of a high-level hand-waving example that will give you some intuition into what's actually different. So basically, before deep learning, you would have to tell the system what to look for, right? So an example here could be, I want to train an algorithm to detect faces, right? Is there a face in this image or no face? And then I would have to start thinking about, what defines a face? I could maybe come up with something that could detect eyes and nose, mouth, etc. But the key is really that I have to specify what to look for. And then there are a lot of pitfalls. It's kind of like the black swan problem, right? That you have to think about all the things that could happen, and when you let the algorithm work on real data sets out in the wild, then a lot of things that you didn't expect are actually happening. So for instance, here maybe we don't find all the things that we expect, so we say this is not a face. You could think about another good example of challenges could be, you could think, well, to classify a face, you need skin color. Well, skin color is really different. How do you actually define that? So there are a lot of ways that can go wrong. And there are 2, basically, that's impacting this process in 2 ways. One is there's just a higher error rate compared to deep learning, because you would have to feature engineer, you would have to think about all the things out in the wild that could actually happen, and you're just not going to get that right all of the time. The other thing, which I think is really key for this, is that the model creation process is to some extent manual, that you have to define what features to look for. Right, so if it's a face, you'd have to say, well, I need to find eyes, I need to find a mouth, etc., to say this is a face. If it's a bicycle, you'd have to think about what defines a bicycle, a saddle and wheels, right? So that's not a very scalable process, and that's one challenge that deep learning has overcome. So let's take a look at how deep learning actually works. And the really cool thing about this, and also one reason why it's being applied to so many different problem areas, is that it's so easy to use. That basically what you do on a high level is that if I want to create a model that can tell me is there a face in this image or no, then I would simply find a big data set with a lot of faces and a lot of images that are not faces. Then I'll label them faces and not faces, run them through the algorithm, and then I have a great classifier. So that's really why deep learning is so powerful, that it basically, you don't have to tell it what to look for. It builds that model, that understanding itself just from examples. And I think it's very similar to how humans work, right? That you don't have to tell people what to look for. You show examples of stuff, and then I learn to recognize that. And I think one fun thing I wanted to show you is that you can actually go into a neural network and take a look at what it's looking for. So here, on this next slide, I have a neural network. So here are 3 different cross sections of the network. Don't think too much about what that means, but it's different representations of what the algorithm is actually looking for. And this particular one has been trained to look for faces. And I think it's fascinating that without telling it that to look for, a face, look for a mouth, or whatever, it actually finds that out on its own just by looking at examples. So if you take a look at the left piece here, you see high-level representations of faces that it's looking for. And then the middle looks for more details like eyes, nose, ears, etc. And then the right-hand part is hard to understand. It looks for some kind of edges. But it really illustrates how the power of deep learning, that it defines what to look for. It figures out what to look for, basically, on its own, and you don't have to specify that. Okay, so shifting gears a little bit, I wanted to talk about how the kind of dynamics between humans and AI. So for some topics, some fields, you would think maybe AI is just going to take over and do our job. And but actually, for a lot of things, studies suggest that you get the best performance from a hybrid between human work and AI work. And this is a really interesting study, I think, that's on breast cancer. And basically, you have all these images, and we're trying to figure out if there's a tumor in the image or not. And it turns out that if you can train an AI model and get similar performance to a doctor, a trained doctor, or actually slightly better, which is tremendous. It's great, because then you'd think maybe you don't need the doctor to do this tedious job of going through all of these images. But it actually turns out that you can do even better. And if you combine the AI model with the doctor, you can get much better performance. And how can you understand that? Well, the reason is that then the doctor doesn't have to look at all of these images. You can simply have the AI model find the ones that are likely to be a problem with, and then pass them on to the doctor, and he will inspect them, those images in more detail. So it's something we're thinking a lot about. How do we actually think about the job that our users are doing, and what can be taken over by AI and how those things combined. Okay, so let's dive into how does this actually work. And it's super simple, really. For the dam, when you upload an image, it gets sent to a neural network, and you get tags back. We even send very low resolution images. It turns out that's just as good as high resolution images. So it's very lightweight and very easy to use. You don't have to do anything. You can bake it into just the ingestion workflow. And the tags you get out of it are pretty remarkable. So basically, we're looking at tens of thousands of different tags across a number of categories. So stuff like what type of photo, macro, portrait, etc. What type of activities, if there are people in the photo, emotions, objects, location, etc. So it's really a broad range of tags that we can apply, and it's something that's also representative of what users are actually searching for, right? So it's there's a lot of value to this, and then so that's how it works. But what do we actually do with the tags? And we're thinking about there are three different ways you can use these tags, right? You can, if you have an image that has user-generated metadata already, you can add that in a different place. You can append it, so basically just put it with all the user-generated data, or you can replace it. And what we're doing is we're looking at the first scenario. We just add it in a different place, so there's no, like contamination or anything. If you user-generated metadata, if you're worried about that, it's stored in a totally different place. But it's then enabled. We're enabling search on that, just as you would on the user-generated data. And talking about search, the next slide here points out an important thing. So when you send in an image to the service, you get not only the tag back, but you also get a confidence score. So basically, how confident is the algorithm that this tag is really accurate for this particular image? And that turns out to be extremely useful because we rank the search results based on that, right? So it makes sense that if I search for something, I want the images that the algorithm is very confident that matches the search query. We want to show them first. And then the additional part is that that's a score that goes from 1 to 100. And we assign the maximum confidence to the user-generated metadata. So if I tag something, we trust that the user actually know what he or she is doing. So we have assigned a confidence score of 100 to that tag. So that means that the manual things will bubble up if they're relevant, and if not, we will bubble up the auto-generated, the images that match the auto-generated tags. So it's, I think, a really good way of balancing the human input and the machine input to give you a search experience that, it can never be worse than it was before. It can only get better due to this this ranking. Okay, so let's take a look at a specific example here. And so here I have an image, and I get some tags back. And so as I said, this is an extremely easy feature to use. You just send in the image, you get tags back. You don't really have to think about anything. But there's one parameter that you need to set, and that's the number of tags you get back. And basically, it's a balance between search performance and richness of tags. So basically, you don't want too many tags for each image, because then the indexes you have to build to search get really big. But you don't want to have too few, so you don't have the richness that you could actually get out of this. So typically we say, recommend about 10 to 30 tags per assets. And then one more thing I wanted to mention here is that if you look at the tags here, you'll see that at least one for me stands out a little bit, and that's the T1, right? Is that actually that accurate for this? And then we get asked, well, should I curate these tags? Should I, if there's something I feel like it's not really accurate, should I do something and delete it? And it turns out that you can obviously do that. It's great. But a lot of times you don't have to do that. Most of the times you don't have to do that simply because of the ranking based on the confidence score. That, say I search for T, would I like this picture to show up? Yeah, maybe. If I had something that's more relevant, I would want that first. But this is not, bad for that search term. And what's going to happen when I search for T is that if I have an image that's more relevant, then that probably has the tag T with a higher confidence score. So it's going to be shown before this one. And that's really, it's a really powerful concept that maybe it's obvious, but it turns out for large repositories, this is an extremely important concept that makes curation of the machine-generated tags much less important. Okay, so that was kind of some fundamentals on how does it work and some more tactical details on the outputs. Let's turn to how we can actually use this, and we have 5 examples specifically for the DAM. And the first one I wanted to talk about is stock photography. So we're running this site, Adobe Stock, where we sell stock photography, and we use this technology, and we use it in 2 ways that I think are kind of interesting. One is that we tag assets so they're findable, just like the DAM use case. So that's a no-brainer. But there's an interesting thing going on with stock photography that actually, as someone who's contributing stock photos, you have this kind of perverse incentive to over-tag your images simply because you want them to get found, so people can buy them, you get paid. So people tend to tag their images with even like borderline relevant tags, and we're not interested in that as a platform. We want people to get high quality images, and there's no way for me to tell if someone tags an image with a really useful, good tag, or it's like a borderline useful one. Right, I would have to go through a manual process to do that. So here we use this technology in an interesting way, where we say if an image come in with the user tags, and then we run the AI algorithm on it. If there's a match between the manual tag and the automatically generated tag, then we'll boost the search relevance for that. So I thought that was kind of an interesting way of leveraging this technology in a different way. And then let me move on to the next example, the final one I have before handing it over to Elliot. And this is about user-generated content and how deep learning is really important for this use case. That you may, as organizations, have a lot of influx of images, but it's probably nowhere close to if you open up for user-generated content, right? Social media, it's a different order of magnitude. So the scale goes up, and you really need some kind of automation. And deep learning is great because it scales so well. It's really fast, so it's easy to tag images. And you could also have more specialized use cases. For instance, you want to filter non-safe for work images, off-brand, etc. You can train specific classifiers to take care of that. So UGC is a huge area for this, simply because of scale. Okay, so with that, I'm going to hand it back to Elliot, who will walk you through the three other examples.
Yeah, so thanks, Jonas, for that. I mean, I think Jonas gave us a great overview of some of the core fundamentals of how the technology works, how these tags are populated. I mean, how we're taking advantage of these new algorithms. I mean, if you look at what we're doing with Adobe Stock now with UGC, I mean, take just a quick stat that we pulled on how much content is out there from UGC, which is, I mean, this is one of those use cases that we've been hearing quite a bit about from the community and our customers about how can we tap into all that content that's getting created. So, I mean, this just looks at, the sort of behavior of our consumers that are out there. Some of these are even our employees, of how much content is created on a daily basis and shared through this content. It's an amazing stat that's happening. And then when you think about that world of how that content, if that content should make it back into the dam, we're going to need a different scale of tool, a different tool that can scale to help us quickly sort through that content to find things that are applicable to our business. So very interesting phenomenon that's happening there with the user-generated content. Another example, so another hotel brand that we're working with, global as well. So you think about the travel and hospitality industry and, the typical hotel. Many of them, when they're working globally, they run through the various scenario of, they have content from a lot of internal or external agencies. So some may hire their own internal agency to go around, take photos, or leverage content for their global marketing brands. But they also, just like many of you as well, probably tap into a lot of external digital agencies to help boost productivity. But they're also working with a lot of franchise partners. So depending on the hotel brand, some aren't wholly owned units. They do franchise that out, but they do want to make sure that those franchises are using the latest centralized content, but at the same time, they have a way to create and publish and source their own content. But then the hotel does want to have a say to do some kind of brand approval just to make sure that, things look consistent, right? So then being able to kind of repurpose that content and share it as well. Commercial partners. So you think about the brand products that they have, like credit cards that they usually partner with, airlines, different events, lots of different types of partners, local guides, depending on the type of business, where they have content too. And then they need to get that into a centralized system to help accelerate the process. And then, of course, as I mentioned before, users. So this has been actually, the second example that Jonas was talking about sourcing from user-generated content. Our travel and hospitality business, we've seen that part pick up quite a bit, where we've seen those candid, authentic imagery from the vacations. Those want to be repurposed by the hotel brands themselves. I mean, if you think about the way that, I'm going on a vacation or I'm going to shop at a place nowadays, I typically try to look at, what's there, but as well as, what are the users saying about it? And seeing those real source content in there brings a lot of validation to their business. So, we're seeing they're sourcing a lot of content from a lot of different places. But their specific challenge is they're getting up to 1,000 different pieces of content per day. So to manage that influx in there, you're still going to have human involved, but you need to have some assistance there. They're also encountering the incomplete metadata challenge, where we're seeing for terms that are in there, but the part that people aren't entering in as metadata has been the more subjective description. So think of words like calm or exciting, things of that nature. You may be able to train some users to add some of that data in there, but the full breadth of sort of suggestions and ideas that may come from a platform might be a little bit broader than what a typical person could come up with. In some cases, they get a lot of duplicate or similar content. So, if we see a lot of people sourcing in imagery from Rio de Janeiro, and they're taking the same picture of the Olympic place and sending that back into the hotel only needs so many of those, right? So they want to make sure they can quickly filter those out. So, lots of different challenges are helping them sort of be able to quickly sift through content, help them tag that content a little bit more accurately and with a broader sense, and identify duplicate content has been one of the key challenges there for this global hotel. One other example, a global publisher. If you think about a lot of our publishers that are out there, that I mean, they are in the business of creating content. Whether you're publishing for a magazine, publishing for a web series blog, publishing for TV, you name it. You are creating a lot of content. You're licensing a lot of content. You have lots of content producers in there. You want to create a lot of content that's fresh, but in many cases they want to also repurpose a lot of content as well. So one thing that was here that's very similar to the hotel use case is, again, getting a lot of new content per day, so 200 to 400 assets coming in under tag. But I think one of the key points here is that the purpose of this asset may change over time. So, for example, in this example here, the original asset may be tagged, for a specific article, and they were talking about a yoga studio, and they likely had a common piece of artwork here, which is very generic, just talking really more about the yoga experience. They may want to come out with a different article later on, maybe a year or two later, talking about just women in fitness, where they want to be able to repurpose content that they may already have. So that content that was created, a year back for a specific article, they could find different innovative ways to repurpose that content and then keep their cost of production down, as well as help identify and find content that'll get their content out to market faster, right? So, it's a cost-saving message, as well as a speed message where, publishers, they're competing for eyeballs just as many as everybody else is, where they need to come out with a lot of content very quickly. And then finally, we'll end here on a consumer electronics company that many of us are familiar with, where they're using assets in multiple places. So you're using it on their website, their mobile apps, their regional websites, partners as well, or have a lot of reselling partners who may take their device, the consumer device, like a phone or a laptop of such, and they may want to publish that out on a different type of channel. So they're using the assets in many places, as well as getting the assets created from many places, just as many people are doing as well. So from the photo shoots to the design agencies who are coming up with different themes for their global marketing campaigns, those are coming in. So that actually presents two different challenges. One, for the assets that are being used in multiple places, how do they know how these assets are performing across channels? So is that asset even performing well in their own website, to understand that? And then is it working well on those other partner websites as well as third-party websites where they might be able to get? So getting that data back into the central repository has been one key ask there, where you can start to take advantage of that data to help push the business forward. Second, for the agencies that are creating all that content, how do they understand which one is good? So you're working with a lot of agencies, creating a lot of content. A lot of agencies actually want to get to this data as well. They want to understand how well was it content being resonated? Did it participate in the conversion for that campaign like that we thought it was? Should we be able to repurpose or reuse certain themes towards different segments? So lots of different opportunities that we can use when we start to tap into getting this data back into that centralized repository. So lots of different examples here of how from across different industries are looking to take advantage of leveraging this data and insights. So there's several other applications for this technology. So from creating more custom tags. So right now, the systems are putting more generic tags to help you understand a bit more of the content. So for example, location and understanding if you're seeing the Washington Monument, for example, or is it a calm scene? Is it a scene of a beach? Things of that nature. Getting into more specific content, so maybe you might have very, very unique products that aren't available yet, or maybe very unique to your brand. How can you train the system to recognize that brand and maybe map to your controlled vocabulary? So a lot of interesting areas there. Similarity search, right? So this is a very natural way to go into there of just seeing which assets look very similar to other, just based on context, look and feel, performance, etc. Recommendations. So depending on how the specific user interacts with the dam, think of a world where the dam no longer is a place where you just do search and then it gives results, but based on your previous history, based on your role, based on your campaigns, different kinds of content is actually suggested to you automatically. So the machine is actually thinking ahead and pushing some suggestions to you of maybe different pieces of images or videos that you would like to use in your campaign. And of course, video, right? So, we were talking a lot more about imagery. I mean, that's sort of the primary use case where most people talk about first. But video has been, there's been an explosion about the amount of video uses. I mean, we've even seen a 5x increase in terms of video streams that we've done here at Adobe. And our customers are asking, well, okay, now that we have this video created and streamed, how can we take advantage of these different algorithms to help identify some of the content that's in those imagery, or use that in more intelligent ways to extract audio and more. Use the latest algorithms to do that is the goal that we have here. So there's many others that are here, from text recognition to speech, et cetera. But there's many applications of this technology that I think we're going to come to expect as our DAM systems continue to evolve. So, I think, one of the key areas that we want to close on, and we'll get to questions in a moment. So if you do have questions, start to place them in the chat pod. Artificial intelligence and data science, I think we're going to look at this as a very efficient tool that we're going to have to help support the business process that we have today. So the idea is we want to get our teams to move faster. So we've seen the ask to the content creators, the content managers, the content publishers just increase dramatically over time. And the ask to get content out faster, get it reviewed faster, finding that content faster is going to be speed is going to be one of those things there. So how can we leverage these systems to make it faster? How do we make it more efficient? So the one that I keep thinking about is the DAM user that keeps browsing around, searching for the right asset in the DAM. So they're spending a lot of time searching for content, and then when they find a set of content to use, the question is, okay, well, which one should I use for my specific goal, my specific business goal? Most people aren't just I would like to think they're just browsing around our DAM because they just like hanging around there, but no, they're going there for a specific business purpose. And we should present them with all the relevant data so they can make that right decision at that point in time. And then overall, just higher level intelligence. So the system being able to actually predict what we want to do. When we combine that with the human interactivity there, we can be much more productive. So as we're getting ready for questions, so we have a little bit of audience participation because I think this is going to be a little bit of fun. Where we're actually going to show you an image, and so get ready to look at the screen here, and then would like to know if you can predict the tags. So to predict the tags, I just kind of want to see what people are guessing right now. Let's call this a sort of a pseudo crowdsourcing experiment. Type into the chat pod, to the chat pod or the question pod, what your guess is for this image. So here's an asset that's embedded into the DAM. So there's no metadata associated right now. So we kind of stripped all the metadata out. And you can see the file name is named poorly. We've probably seen a ton of these. File 21 JPEG. Type in what you think right now is what potential keywords could come out from this one. And then I'm just very curious to see what comes up. So I'll give everybody about maybe 30 seconds. And the idea is to look at this and then type in what you see there. Okay. 30 seconds going fast. We got about 15 more seconds. So what other? And you can type in more than one if you want. So if you think that's you have one keyword in there, that's great. You can type in more than one. I'll see that. Okay, so let's see what it came up with. So we're looking here, we see concert night, background dance, entertainment, light, music festival. Yeah, I think some people had some parts in here, right? But if you think about the breadth of what people could potentially search, I mean, when I'm looking at the question responses that we had come in through here, we have some people who named multiple. So I'm seeing someone mention concert, crowd, event. So you got quite a few. But look at the breadth of the different tags that came in where people could have been looking. So look at the silhouette one, for example. I wouldn't have come up with that, but you never know when someone's actually searching and looking for those kind of things. this is the type of learning that comes out from the different systems where, we start to think about, enhancing that search experience. And these are the type of tags that are going after you. So that was a lot of fun. Thank you all who participated. Quite a few tags that are in here. And you think about the evolution of this, I think it's going to be a bright future. So with that, we're going to get to some next steps and some practical advice, and we'll get into questions. So one of the first pieces is build the business case for this. So it sounds like it's always fun to have a nice, cool piece of technology come into the business, but when we're thinking about productivity, cost savings, and things of that nature, or making your workflow much more efficient, you have to build the business case before we get acceptance for this. So think about how we can tap into these technologies, maybe more specifically for your organization and your business challenges, and how do you align these different techniques that we talked about to something that can solve a particular problem that you have today in your particular workflow. And so think about what data will make the biggest difference to your stakeholders. As you're pulling data back into the DAM, the usage data of just where that content is being used, like is it being used on social or is it being used on web, has been important. But we've also seen some of our customers as well say, that search data. I want to know when I'm doing a search that I'm also searching for the asset that's been used the most, because they want to be able to see that in where they're stack ranking their search results as well. Understanding what type of data is out there and which ones you want to pull in is important. The third one, which I can't emphasize enough, is do not, I'm going to spell that one out, abandon your metadata and taxonomy strategy. So think about really more about how this can be a tool to augment that strategy to make it better, not a all-out replacement. Maybe one day it turns into a world where everything gets automatically populated for us, but right now it's about making that search experience much better for your users to the strategy that you already have. Then the fourth one, this applies to when you're introducing a new set of technology, but particularly to most DAM projects at all, is really starting small and then expanding over time. We've seen our teams sort of introduce too many technologies, too many different workflows, too many different pieces at the same time, and then just the organization it might crush underneath the organization's own weight of getting that out. So there's so much that you can learn when you start with a more of a focused POC, when you launch small, pull in this technology, and then see what teams will be applicable to before you start to roll out to all the other teams. So this is common advice that you probably heard from many other projects, but it still applies here as well. And then finally, don't create another data silo with your DAM. I think we have a lot of data already in the DAM. How can we tap into those other data sources to make it much more practical? So I'm going to open it up for questions. I think we have a few questions here. So let me go to the question, and then we'll go through each one. Great. So so let me start with the first one here. So this one, Jonas, I'll field this one to you, and then we can comment on this one. So it's really more about teaching the AI to use your own taxonomy and own terms rather than its own vocabulary. So maybe it could be helpful to explain, sort of the current state we are today with the more broad tags, and then I think this is more about the custom, more specific tags.
Yeah, sure. So that's something we hear a lot. Obviously, that the generic tags are great for a lot of use cases, but you want to get more specific. And I can say it's something we're working on, and it's something that looks very promising. I can't really give a timeline or anything like that, but it's definitely something that that we're looking into, and that there's a lot of demand for.
Yeah, exactly. And so I think the idea there is again, kind of the same approach to everything else. Start with a very focused problem, and then you kind of roll out to there. So as I mentioned before, finding the use for those broader tags that are out there, and then getting much more specific over time. Yeah, so I guess then another question came in, said I tested this in different dam systems, and then the results were broad and not in terms that our users were really searched by, and it was making it difficult uh, to drive adoption. So again, testing that content is incredibly important. Taking a look at the technology of how those tags are generated is also another very careful thing to do. Where I think, as Jonas mentioned before, there's sort of older methods that were less accurate to produce the breadth of tags that you would need. There wasn't a repository of growing tags that sort of expanded over time to be more applicable to users based on some real users results. So you'll see a difference quite a bit when you start to test and use this with different systems, which is why one of the core reasons why we're developing this internally at Adobe using the knowledge that our teams has of rich media, data science, and then bringing that together. Accuracy is going to be the key piece to drive adoption. So we think it's going to be one of the core pieces of DAM moving forward, and it's going to be just one of those things that just must be there. And then this one, I think, might have been answered already through the presentation, but I'll turn it over to Jonas. So are the images in the training set tagged already?
Yes, so that's a key piece. So basically, for deep learning, there are two phases. One is the training of the algorithm. So basically, you can think about it as millions of different parameters inside this model, and for each image that comes in, you tweak those parameters a little bit. So here you rely on large quantities of well-tagged images, and so that's the first piece, and that's something we did in all labs, and that's all done. And then when you want to classify an image afterward, you just send in the image, get the tag back, and that's a much more lightweight operation. So yes, a large data set of high quality images with high quality tags, that's essential. And we're really in a lucky position because we have Adobe Stock, which is a fantastic data source for training these models and experimenting.
Yep, yeah, exactly. And think about the stock service that grows over time. And then I think this kind of goes into the next question I see here is what cloud service AI was used to generate the keywords from the image of a coffee cup? So I think we kind of mentioned in a few ways. So this is actually our own Adobe technology. So you may have heard of the platform that we introduced that spans across all Adobe products, Adobe Sensei. That supports our Creative Cloud products. So that same machine learning technology helps us from identifying stock photography to selecting an image in Photoshop to helping us tag images in the DAM. So that platform is one that we mentioned, we actually announced earlier this month, and we plan to see that expand into more Adobe products and eventually out into the community as well. So you can actually integrate into other applications to tap into the Adobe Cloud. How mature do you see the DAM vendors being now and then using data-driven AI? I think from my perspective, I'll say right now we are just at the very beginning. I think where we've seen is there's sort of been a revolution of this was attempted maybe 10 years ago, where I think things are a bit early then, when we didn't really have the large data sets there. Big data wasn't really even a term. The hardware was very different. I mean, if you think about where the hardware is going now, where it's not necessarily just something that you just do on your own server, but you're starting to leverage GPUs and other different kinds of hardware to identify imagery and video. And then all that's coming from some kind of cloud service, et cetera. So we're starting to see a lot of different DAM vendors, wanting to tap into this. I think our approach our strategy is a little bit different, where we're doing it deeply from within our own cloud. So that's there today. And I think this goes along to another question is, which commercially available DAM solutions are available to auto-tag images today. So I won't speak for the other vendors. I mean, there's other vendors out there who do some kind of content extraction out there. I mean, Adobe experience managed assets, we do that as well. And that's it. Let's see more questions. Give me a second. Do you see automated tagging working in other languages than English at some point? And Jonas, I'll turn it over to you, and then I can comment on that one as well.
Yes. It's the short answer.
That's great. All right, so then, and then I think you might have answered this one already. Lots of questions that are very similar. Does Adobe use 100% AI alone for this auto tagging, or is it augmented by human users inside or outside the client organization?
Yeah, no. So this is an AI service, so it's 100% artificial intelligence. Yeah, so the kind of the human AI interaction happens after the fact. You know, if you want to curate the tags, etc. But the actual tagging is an algorithm.
Yeah. So then I guess another one. So can you teach this AI to the company's asset types like car parts or hotel brand logos? I mean, maybe this goes similar to the question around custom tagging.
Yeah, absolutely. I mean, it's something we're working on. It's where these things are going for sure. So that is going to happen. Yeah.
Got it. And then if there's data silos already existing between separate DAM information systems already in existence and recommendations to how to build these systems, or is it best to recreate from scratch? So fantastic question about how to take advantage of the data here. I mean, it might be too short for a short blurb. I mean, the strategy that we've taken has been to connect to those other systems where they're sort of the system of record. So think of whether you're leveraging a web data from a web analytics platform and pulling that back into the DAM. It's really more of a pull and a mapping to the DAM to help improve that search experience where, you know, you don't really want the DAM to be your system of record for your analytics platform, right? Those are two sort of separately different purpose-built systems. You know, we've seen the similar pattern with product information as well, where many customers maybe use many different master data systems and pull that back into the DAM as well. So it's really those common strategies of bridging the systems rather than sort of recreating some kind of Uber repository. Okay, and then here's another question. So is the image analysis technology at a level that it can benefit for image collections with images of art and images with more or less abstract content?
Yeah, good question. So I think you really have to try it to see, because there's so many. We did a lot of testing. I'm not sure if we did any in that particular area, but yeah, you just have to, you know, try it out and see how it works, and if you get value out of those tags. And again, this would also be a great opportunity later on when you are able to do custom tagging, that, you know, you can train classifiers to you know, classify that specific corner case. But without having seen the particular images, it's really hard to answer that question.
Great. So it looks like we are coming to the top of the hour. I know there's a lot of there's lots of other questions that we weren't able to answer. Great to see everyone engaged here, but unfortunately we will have to come to an end here. So, but do invite everyone to stay connected with Henry Stewart, Adobe as well. If you want to reach out to us, you can shoot us a quick email here. We can answer any of these additional questions that you may have about the technology and how it's evolving over time. And thank you very much for joining us today, and hope to see you in the next DAM Learning Series webinar. Thanks, everyone.